So before we get started on the video, I just wanted to tell you guys this video is to basically show you guys the finished product of the drone. I pretty much finished everything that I wanted to do on the plane, and I've added what I wanted to add, I've upgraded what I wanted to upgrade, and it's at where I wanted to be at. So let's get into it. So the main change that I implemented on the drone was the 360-degree servo. I was looking for it forever and I couldn't find it, but eventually I found it. Um, I'll put the servo name and the serial number in the description so you guys can, if you want to copy something similar to my setup, you guys can. And instead of having to mod a servo in a certain way so that it'll go on 360 degrees non-continuous, this one digital servo does it for you 360 degrees all the way around. It stops going all the way to the left, it swings back all the way to the right, and stops at 360 degrees. So it's perfect, it's not continuous, and it works like it's supposed to. So up here nothing has changed. The VTX is still the same as we did the update last time. GPS is still the same, antenna is still the same. It's the same Rush FPV solo tank VTX, same Fox 012 DBI antenna that I have. That's actually both on my Fat Shark goggles and on the plane itself. And same GPS and magnetometer. Nothing has changed up here. So back here I've changed the 60 amp ESC to an 80 amp ESC. I'm going to be wiring two 8,000 milliamp hour LiPo batteries in parallel, so that we'll be able to get more range with it, and together it'll be 16,000 milliamp hours. And I did the math with the voltage and everything, and I need to upgrade it. And not only that, I could have just stayed at a 60 amp and just gone up for a higher voltage ESC, but I just decided to go with an 80 amp and go that route just in case, just to be safe. Inside the plane you can find an F765 wing flight controller, an R9 receiver for long range capabilities, and a plethora of sensors from FrSky to transmit that telemetry from the plane to my transmitter. I still use that information as a backup in case the plane goes down. That way I'll still know exactly where the plane is. It has the GPS, the airspeed sensor, and the current sensor. The F765 wing also has all of that stuff already in there. But as for the airspeed sensor, I have that wired and passed through so that it can feed that data from the airspeed sensor to the F765 wing, so I don't have to buy a separate sensor. I can just wire it through and it'll read that data still. Here nothing has changed. The landing gear is still the same. I was experimenting with different wheels. I do want to go with a larger wheel type, just in case, because these wheels are a little small and I'm worried about it. I did some drop tests and to see how the plane held up, and it bounced. It held its own very well. The landing gear held up together. The wheels are just a little too small for my liking, so I might go a little bit bigger. If you want to do the same configuration as me, make sure you use a high torque digital servo for the steering servo, because if you don't, and you try to use one of those 9-gram servos, it's not going to work. It's going to struggle trying to turn that wheel. So make sure you use a high torque digital servo for the nose landing gear. Back here nothing has changed. It's still the same 11 to 12 inch prop with the 910 kilovolt motor. I was thinking about changing it out, but I wasn't too sure about if I wanted to do that, because if you want more power, you have to go and you have to get a bigger prop, but this prop was already the maximum size of which I feel comfortable with, and that matched perfectly with this motor. If you go in a faster motor, the smaller it gets, but that means you have to pick a smaller prop. If you try to put a big prop on a small motor, it'll burn out the motor. So if you want, as when I'm saying smaller motor, I'm talking about in the kilovolt or kV rating. So if it's a 1500 KV rating, you can start going with a smaller prop. But if it's a smaller KV rating, you go with a larger prop because that means it has more torque to spin that prop and actually get it up to speed. If you go with say if you were to do a 25,000 kV motor and put the massive prop that I have on it now, it would burn out the motor. And as you see in this footage from my goggles, you can see that the plane actually pivots all the way around, not the plane, but the pan and tilt, it pivots all the way around 360 degrees. I did limit it just a little bit just so that it won't cross over. You can see the lines inside the video on the plane where they meet, so that they don't go all the way over to the left or to the right, so the wires won't get pinched. And they won't get pinched, but just as a precaution for myself, you can just go into the outputs tab in Inav and set the PWM range from 500 as a min and 250 as the max, so that it'll go make that full rotation regardless of where it's at. With that being said, thank you guys for watching the video. It really means a lot. If you enjoyed it, please give a thumbs up and subscribe if you haven't already. And I'll be making more videos in the coming days. I just finished up this plane and another one that I've been working on, a T-28. And I put landing gear on it. And so yeah, I'm gonna be taking both of the planes to the flying field soon and record some footage of me flying them. I'm gonna be doing just regular testing on the drone, on the UAV, and basically just trying to figure out the flight characteristics, see how it flies, see how it handles. I will be modding it so that I do have yaw control, so I'll put servos on the vertical stabilizer so that we have yaw control. The Skyhunter planes, they don't ship with yaw control. It's mostly just yank and bank, so I'm going to be putting the rudder on the plane so that we have control in the yaw direction. So yes, with that being said, I love you guys, and I'll see you in the next one.